This is Mr. Beck Does Your Homework, Physics, homework number 11, questions number 2 and 3. It says a 29-kilogram chair initially at rest on a horizontal floor, so let me draw that. Here's my chair. I know it doesn't look much like a chair, but I don't care. Requires a 376 Newton horizontal force to set it in motion. Once the chair is in motion, a 340 Newton horizontal force keeps it moving at a constant velocity. So I've got two things happening here. I'm going to have a push force of some sort. I'm going to have a normal force, I'm going to have a gravitational force, and I'm going to have a friction force. This says, what is the coefficient of static friction between the chair and the floor? Well, the static friction is the friction to start it moving. And the friction to start it moving is going to be 376 newtons to set it in motion. So I know that my force of friction for static, S for static, is going to be 376 newtons. If I want my coefficient of static friction, that's mu static, it's going to be my force of friction static, FFS, over my normal force. Well, my static friction is 376 newtons. What's my normal force going to be? In this case, since I have horizontal forces and vertical forces, and nothing else vertical or horizontal, I know that my normal force must equal my gravitational force, and it's a 29-kilogram chair, so this is going to be that my normal force equals my gravitational force equals the mass times the acceleration of gravity. That's going to equal 29 kilograms times my 9.81 meters per second squared, and that will give me my normal force. Well, force of friction over my normal force gives me my coefficient of friction, and that will be the answer to my problem. Looks to me like this is going to be about 290 and this is about 376. So in this case, I'm going to get a coefficient of friction greater than 1, which is not normal, but for this case, it's just the way Texas picked numbers. Now, the next problem says, what is the coefficient of kinetic friction? Well, I've got the same free body diagram, but now it's in motion. So again, my push force to keep it moving at a constant velocity, here, keeps it moving at a constant velocity. Well, that means that these two forces will be balanced. My push force is going to equal my friction force moving at a constant velocity. Otherwise, it would accelerate. So in this case, if it takes 340 newtons, I know that my force of friction kinetic is going to be 340 newtons. So my coefficient of kinetic friction is going to be my force of friction, which is kinetic, divided by my normal force. Well, I've already figured out my normal force. This shouldn't change. And my force of friction kinetic is 340. So now I've got 340 over this same normal force, and that is going to give me my coefficient of kinetic friction. And that is my answer to that problem.